Hey Artie, hope all's going well. Just put this video together to show you how to go from AutoCAD to finished 3D model. So the AutoCAD side of it, you know much more than I do. Basically, you make a solid at some point, and then there's a command. You can see here, this is especially for you, we have Artie. There's a command called STL out. And it'll ask you if you want to create like a binary STL out. So you just select whatever it is and create binary STL file, yes. And then here, you just save it. I'll just save it on my desktop here. And this is Artie.stl. Now it can be more than STL files, OBJ files work and all that as well. But the STL seems to be the most successful. So that's the end of AutoCAD. Once you get to that, that's really STL is all it needs, and then you're done with it. The next step is, now that we have Artie.stl, there's a program that I use called the MakerBot software, and it is free software. And okay, it says it's too big, scaled if don't scale, scaled fit. So of course AutoCAD didn't have any units, so I just did, I think it's 20 high and 100 tall. So it's actually a pretty big Artie. So this is the MakerBot software. You can see this is the version here, and it's exactly what it's called, is the MakerBot desktop beta version 3.10.10.13.64. So within here is where you do all of the stuff to the 3D printer. The goal is to make a print file that is an X3G file. You put it onto a USB or the little flash drive, and then the flash drive goes into the printer itself and it reads that. So the X3G file has all of the toolpaths required to make the actual solid. So I'm going to click around on a few things here and show you a couple different things. So get this software again. This particular one, you can get it on the internet, no problem. So I guess first is you want to make sure the printer is set up correctly. This is where you can kind of go online and you can find out different parts that people use. You've got all these different aspects of it. For the PLA, some people say you don't want a huge platform temperature around 45 and the extruder temperature around 230. This is where I really don't know that much more than anyone else. It just seems to be what does and doesn't work. The travel speed, you can see between the settings here, you got your different temperatures. I would expect the travel speed to be faster on the low quality ones. Anyways, so just on standard, these are the settings that I've got right now. The extrusion speed, your fan speed, all in there. There's the infill. Infill is an interesting one. You can choose what sort of pattern you want to do. Also, you can do the layer height and then the infill density. This has a huge effect on how long it actually takes to print the object. If big infill density, you will find that like the orange tools on my desk, I think we did like a 10% or not even a 10%. I think it was like maybe only it would have been 5, and it's still very hefty. So I wouldn't imagine you needing much more than 5. And of course, if you do 100%, then you make an actual solid piece of plastic. That would take a really long time. So this is the biggest factor that affects the amount of time. Also, your infill pattern can, if you do certain things, you can make it a bit faster than other ones. I just use the hexagonal. I mean, it seems to be nice, but you can play around with this, and you'll see where this comes up in the next little bit. Model properties, layer height seems right. The number of shells. This is obviously the outside of the solid has to be solid. It can't be just infill. So this is how thick, I mean, just what it sounds like, the shell on the outside. So 2 shells seems to be pretty good, but if you want to make a bit more of a robust bit, or maybe you have pieces that fit into each other, you can bring it up to a whole bunch of different shells. Roof thickness, floor thickness, coarseness, again, I just leave those as is. Multi-material printing. This is if you want to combine the two. It's got 2 print heads on that printer, so you can actually have one print the raft material being the material that goes underneath like the support structure, because obviously it can't print like an incredibly long, it needs to have something underneath, otherwise it'll droop. So what you can do is have it print a different raft material, and I haven't really played around with that. For the stuff that we're doing, it doesn't seem to come up as a necessity all that much. Again, here's my settings there. I don't know much, I don't do much with those ones. The raft, again, this is the rafting that would go underneath the beginning of the object. To me, your best bet is to place the solid face down on the plate. And I don't like raft, because then you have to pick it all off, and it always looks like junk. So I try to avoid rafting if possible. But again, it's the option here if you want to do it or not. And then supports and bridging, okay. Again, I just leave this one as is for now. For the solids we make, the infill does all that. But let's say you wanted to make Big Ben Bridge. To print along that, you might need to add a support material, but then you have to take it all out. I find the support stuff is just a pain in the butt. But depending on what you're trying to make, you might need it as well. Breakaway support, I don't know what that's about, but that might be a really good one. Maybe it's a lot easier. Bridging, again, pretty much just as it sounds. Again, all this stuff too, if you search it on Google, it'll tell you a whole bunch about it. This for the extruders, yep, I think it's actually 1.75, not 1.77. And retention distance, okay, fine. Retention speed, extra restarch, okay, this stuff seems all good. And then the extruder there, okay. So, we brought in our STL file, here we are, Artie, and we've set up our printer settings. Let me just see here. Remote printer is connected to a select type of device. You can see I chose the Replicator Dual. That's the one that most mirrors what this ON or these our printer is essentially a rip-off of this one. So this seems to work at best results with this. Normally you choose that first. Choose that before you end up going into all these settings. What else here? All the different previews, orthographic, edit, nothing really right there. That's fine. Background service, that's fine. Okay, so a couple of these things here. This one here, change dimensions. So you can see here if you had uniform scaling, you can do stuff like inches to millimeters. Whoa, right? So that's all 20 inches now instead of 20 millimeters. Reset the scale here. How do I do this here? Maximum size. So that's where, as you know, in AutoCAD, it's a dimensionless system. So when you're designing it, basically you keep inches or millimeters in check, and you do all the actual dimensioning while it's in AutoCAD. Here you just choose which one it's going to be. And for a lot of people, they just want like maximum size that they can get into their printer. But you can also do stuff like this and just scale it down from here, you know, so we can make it a bit more reasonably sized if you do want to use this as a test print. What else do we have here? Oh, this is an important one, because sometimes if you have the solid come in and it's not on the right bit, like maybe you want to have this bit right, I'm pressing middle click to move around, by the way, too. Maybe you want to have this bit right here laying down flat on it. So there you go. You can do plus 90 like that. Oh, wrong one. I guess it's the Y I need to do plus 90. No, I'll eventually get there. There we go. And then lay flat. So you can see how that moves it to what you'd want it to be. But again, if you were focused on you wanted to have really nice finish on the front, the smartest move might actually be to do, God help me. There we go. So the smartest move might actually be to lay that bit flat so that that bit's nice and smooth, because we won't use the rafting at the beginning. But just for demonstration purposes here, let's do that, make it look like this, so it looks neat. Of course, there's the rotation, and Control Z is undo for anything. This is to move it around, put it in the center. Here, if it's up and down, it's not. You put it back to the platform. For example, if I all of a sudden move it back, and it'd be the Z, wouldn't it? Yeah, move it up on there. Okay, put it back on the platform. It's important, but there's center it. Obviously, you just can't start printing anything in there. So this here, I'll send it through the next stage so you can see. This would be a very difficult print for it standing up like that. What you would want to do, obviously, is have it down on its back, like we just showed here. You'd want it like that and laying flat. Like that's how you would print this. But going back to the way it was, Why is this a difficult print? Well, because it has to start here and then build up layers, build up layers, build up layers. So that bridging I was talking about would be this area in here where you could add in bridging material, but then you have to peel it all off. So I'm going to send it through like this, just as a hypothetical print, so you can see what happens next. And then this is just changing your view. So once you get the general sense of it set up there, and the print area of the machine, I can't remember it off the top of my head, I think it's like 8 by 11 inches by 8 inches or something like that. That's also defined by these devices here when we chose the different type of printer. So it should be defined by that, and it should be the same. The next thing you do is, theoretically from right here, we can go right to export print file, and then boom, right here, we want the X3G. And that, all you have to do is take that file, put it into the machine, and then boom, you're off to the races. However, that file is a lot more than just what the shape looks like. Like I said before, it's the tool paths. So when you go to preview here, it'll take a little bit of time. Bear with me. Hope you've dried out there. Get a chance to get back out on the motorbike. All good. So this is an interesting thing here. I don't know if I'm going to make it bigger. Make it bigger. Okay. So this print will have 272 layers, and you can see here where it has to add in these bits to make the structure actually hold itself. So you'd have to go back after the fact and get rid of these, or if you're really advanced, you have 2 different types of material, and you print this out of a different material that you can like acetone wash away or something like that. So this is what it actually prints, and that's why I always like preview, because you can really get a sense of, okay, what's it got to do to have successful printing. And you can also zip down through the layers. So this is each layer of the whole thing it's going to do to make this print. So it's pretty cool, actually. And this is where success will basically live or die, is looking at this and trying to say, okay, is the material cooling quick enough? Is it getting hot enough? Is it sagging and whatnot? But you can see there's 272 layers. Each one of these, maybe it'll show the travel moves here. You probably won't be able to see. Yeah, there you go. This is what the X3G file actually is. These black lines are the exact path that the tool's actually going to take to make all this. So there's even a bit more options you can change there to try and maximize the efficiency. You can see this one says it's going to be about 1 hour and 35 minutes, and it's going to use a measly 19 grams of material, so like 20 cents worth of material. So let's back out and change some of these settings here and see if we can get rid of the rafting, just to show you how, sorry, that's not rafting, that's bridging. Rafting goes on the bottom. But let's put rafting in, and I'll show you what that looks like here. Back to the settings here, and then we're using the standard settings. So let's turn on the raft. And the whole point of the raft, the theory behind the raft, is that you have temperature effects of the cooling. By having it up off a raft, you don't, since it's not touching the plate, you don't have as much curling coming up, because it's a bit more steady temperature. However, that's also why they put a heated plate on the first place. Like, why bother to heat this bottom plate? It doesn't actually. I don't think the rafting's also shit hot, to be honest. I wouldn't recommend it. But again, when you play with it, you'll feel what seems to work for you, and supports and bridging. So no more supports. So it might even be an impossible thing to print now without supports. And adding on the rafting, just to show if this is actually correct and all that. Now it prepares it with these settings. So now, when we zoom in, you see this weird stuff happening down here. That's the rafting. I'm not a fan of it. And it's supposed to help make it so that the, again, differential temperature effects. And if you look at this, there's no support material there. So, to me, what the smartest, it's like an AutoCAD glitch why it looks like that, I think. To me, the smartest thing to do is, if you have a shape in mind, when you're at the AutoCAD stage, that's your best bet for adding in supports. Otherwise, it just does it blindly, and it's so much to clean up. You'll play with it and you'll see. But you can see the rafts are added in there. Now, again, the tool move paths, always great to see. You can see exactly how it's going to come together. You know, it might be able to print that, no problem, because it does have structure going up, and Yeah, it could have no problem with that. I mean, maybe try printing out some archways and see how it works. Of course, changing maybe some of the temperatures and whatnot. But for solid fill objects, that would be the way. So if you really wanted to print this Artie correctly, this is what I would go for. I would go back here, I would rotate it so that it's laying flat on the bed. Lay flat, put it back in the center. So now we're looking like, ooh, back in the center. So now it's looking like this. Here, close that there. So now it's looking like that. Try to escape here. Rotation, that's what I need. Anyways. And then I go to my settings. And here I would be standard. Again, these do matter. It's just, these are kind of the stock ones people recommend. But the infill, let me show you the infill too. So let's change the infill from a hexagonal to a, well, let me show you what the hexagonal looks like first here. So I just changed that to hexagonal. Let's go to the preview. May or may not be able to see it, but when I cut into the layers, okay, there isn't enough space for it, but what that really is this was trying to do hexagons, so that's that fill. At 5%, that's what it looks like. Now let's change the infill again. Let's do, this would be a ridiculous print. 20% infill would be, oh geez. 20% infill, hexagonal, and then preview it. This would take a while too. It'll tell you, like before it was an hour. An hour, 38 minutes. Surprised it's so quick. Now, oh geez, did I get lost there? I did. Now you can see you've got tighter hexagons that are filling in. The rafting's still there. We don't want that shit. So now you got tighter hexagons in there as well. So, infill, 5. Like I would say 5 for most things is fine. But if you find, it might improve the print quality, because if you think about it, that top layer has more of a bed underneath it. And you can do diamond, whatever, linear hexagon. I don't know, Morocco Kinstar. I don't even know what that is. But you play around with this and see what people on the forums seem to say is the best. I don't know, maybe a linear is good. And then as well, the raft, don't want that junk. Supports bridging, okay, put those back on. I don't know, leaky connections, I don't know what that's about. Line support, extra support if it needs more. Maximum bridge length, that's what we talked about there. That's why if you look back at that A, it had bridging on the, when it was standing upright, it had bridging going all the way to here, and then that last bit. So that's just how the math worked out. That last bit would have been the 80 millimeters. It says, hey, that's okay, you can bridge that. So sometimes it's not as smart as a human can be, and that's where you can step in with AutoCAD. Okay, so let's put it at the actual settings if I wanted to print this nicely. Again, you have to choose your extruder that you're going to be using as well. And let's see here, yeah, sounds okay. Actually, this is probably it right there. And then let me see. Yeah, no problem there. Preview. Let's see what we got here. Artie, my friend. So I switched to a linear type of infill, I believe. So you can see it just adds lines in there. I think you might get better results with a hexagonal. But that T would be good because it's got it right there. So again, it's all up to you. The travel moves here. Notice bridging is turned off. So there's all the travel moves there. And that's about the time there. So after that's all well and done, you export, and then boom, X3G file. So for this rather simple one, desktop here, put the desktop. So this is, I'll call it Artie X3G. This takes a little bit of time. This X3G file is gonna be probably, I don't know, 4 megabytes. I know for the tools. Oh, Artie's been saved. That was pretty quick. Let's see here. Artie X3G is 1 megabyte. I stand corrected. So that the megabyte size of it is probably directly proportional to how long it takes to print, ironically, because the bigger size megabytes would be more tool moves and whatnot. And so I've got another program here. I mean, that's, you take that to the bank and you can print it. You see I don't have a thing to open this one there. But I got another one that you can open just for quick to make it easy, like 3D Builder. This is if you wanted other people to print it, you send it to them. It's nice because you can just see it quick and easy what you got on the go. But realistically, buddy, that's all there is to it. And from there, you just put that into the 3D printer, and though that file has all the information about what the temperature of the extruder should be. One thing I will say is watch it in the first few minutes. Make sure it's not doing anything crazy. And when it comes time to lift up the parts, the best thing is that I sharpened one of the little spatulas. Turning on the heat to try and get the parts off the bed, I tried that and it does not work. Also, you'll see in the manual about setting the bed up. It's very simple. You just, one of the options on the screen is where you move it to take it to the different corners and set the depths with the little wing nut screws underneath. I showed that to a bunch of people there too, so that should be an easy one. Other than that, I'm available. It is 8-hour difference here, and it's busy with. Geez, I got here last week, and in 1 week time, going from oh yeah, the new guy here he is to oh yeah, you're going to be acting unit manager, going on vacation, and then the other guy, main area manager, he just left. Like in 1 week time, area manager leaves. The other unit manager for Mondo, he swapped out too. So now there's a new guy there. So it's from well, it's been a crazy time. But get through it, and the guy will be back in 2 weeks, and that's about it. So take care, Artie, and I will be talking with you. Bye for now.